All right, today we're going to talk about ANOVA analysis, which is analysis of variance tests. So this is a great type of test if you're running kind of like a parametric study. So if you're trying to see if there's multiple parameters that has basically a significant effect or a statistically significant effect on the outcome of your experiment. And you can also tell which parameter is going to have the largest impact on the outcome of the experiment. So what we're going to do today is look at some crop data. So this crop data measurements, we can kind of see here and look at how the fertilizer, basically we're looking at fertilizer effect. So fertilizer, we have fertilizer 1, 2, or 3. We also have planting density 1 or 2, low, high density, and planting locations where we put, basically block here. Where do we put the fertilizer, or where do we actually plant our crop? And then the final outcome is this yield, so crop yield. So I don't know if I have this on the computer, so I'm just going to look at this. We call this seed data. So you're all experts in that anyway. So let's go ahead and let's do a one-way ANOVA. So I want to just see, does my fertilizer, so the third value in here, does my fertilizer type 1, 2, or 3, does it have a significant impact on my yield, my output? So I want to pull out, and you can see I have parameter 1, parameter 2, parameter 3, and we're going to see and run ANOVA tests and see if this outcome is significant. So we get a lot of data here. So these are degrees of freedom, sum of squares, mean squares, F ratio, and p-value. And we also get essentially the cell means. What do all these values mean? Okay, so how do we want to interpret this table? Well, first of all, we're doing a one-way ANOVA. So we see this p-value is much less than 0.5. So fertilizer has a significant impact on our tests. So this is good. Fertilizer is important. It affects crop yield. But how can we see, which one is important? Well, we could actually do this post-test Tukey. And we can see in the model basically these cell means, and it gives us essentially a result. So in the model, it tells us 1 and 3 are statistically different from one another. 2 and 3 are also statistically significant as well. But you see 1 and 2 are missing. So 1 is different than 3, 2 is different than 3, but 1 and 2 are statistically insignificant. And here in these cell means, this is showing us, okay, on average, the means, model 1 gives us this yield. Model 2 gives us this yield. They look to be pretty similar, right? But model 3 gives us this yield. And so that's kind of the key thing that we're seeing here. And you can actually confirm that, that these values are essentially the means of those fertilizers. And actually, we can look at it and calculate our confidence interval. See the confidence interval here and here, and here and here, there's significant overlap. But for fertilizer 3, you see that these are not overlapping, very, very close to this one. But anyways, they're not overlapping with essentially 1 and 2. So we can tell that fertilizer 3 gives us the highest yield from here, and that 1 in fertilizer is a significant effect on the crop yield, and that 1 and 3 are statistically different, 2 and 3 are statistically different, and we've done that by actually extracting the data and looking at your mean CIs ourselves. Great. That is a one-way ANOVA analysis, but we could also look at, what about fertilizer and density? Are those two factors significant independently? And then also, is there a kind of combinatoric, is there an interaction with fertilizer and density that has an impact on yield? And we'll talk about that in the next video. Thanks. Bye.